Okay, so we learned how to find an inverse algebraically, then we learned how to do one from a table, and now we're going to find an inverse from our graph, our third and last method. So if you remember, this is what our tables looked like in the prior example. So let's go ahead and plot them. So first I'm going to start with my regular function. And I already plotted my points. So now I'm just going to connect the dots and I'm going to draw my function. And I'm going to go ahead and label it because we're going to have a lot going on and I don't want to lose it. Okay, so the next thing I'm going to do is I'm going to plot the points for my inverse function. So I go over 4, -2, and then I'm going to do 1, -1. Next, I'm going to do 0, 0, and then 1, +1. And my last one is 4, +2. Okay, so now I'm going to go ahead and connect my points. And if we see, let me go ahead and label it. Okay, so if we see our graph kind of do share a couple of points. So there's one important thing to notice. It's almost like if our graph just shifted down to the right. So let's look at something. On the graph, there's a line that is called the y = x. So that is the parent graph for every linear function, y = x. And it's just going to come right up here, crossing the origin, and it's a straight line. Okay, so this is y = x. So that's the parent graph. So every other linear function comes from this graph. Okay, so if we look carefully, we're seeing that our regular function, our original function, is being reflected over this y = x graph. And that is a characteristic that inverse graphs have. All of them are being reflected over the y = x line. Always, always, always. Okay, so that's one way that you can graph it. If you don't have the table and you just have the graph, well, you can just draw that y = x and reflect the points. Some of us can do it visually, others need to have the graph, whichever works for you, that's totally fine. So let's go ahead and do another example. So I've already plotted some points, just so that we can see the graph, and then I have the points written down if you need them. Just give me a moment. Okay, so here is my graph. This is my absolute value graph, and we're going to be seeing a lot of these next week. So I decided let's go ahead and get comfortable with this graph. Okay, so again, I'm going to try to find the inverse function just by reflecting over that y = x line. So if I don't know what it looks like, well, I know it passes through the origin, and since it's y = x, that means that my slope is 1/1. So I'm just going to go up 1/1, up 1/1, up 1/1. And that's what my line is going to look like. So let me go ahead and fill that in. I'm just going to make a dotted line. Okay. So if I were to reflect this graph over the y = x line, all I would need to do is, it looks like, just reflect this line over into our fourth quadrant, right? Okay, so just in case you're not able to see this, I went ahead and did a small table. So let's go ahead and take a moment to find our inverse with a table, get some good practice. Remember, all we're doing is just switching our x and our y. So in this point, my y becomes my x, and my x becomes my y, and I'm just going to be doing the same thing. -1, 0, 0, 1, 1, and then 2, 2. Okay, so it seems like only the upper half of our graph of our table changed a little. So let's go ahead and plot those points. So I'm gonna start with 2, go down to -2, 1, go down -1, 0, 0 stays the same, 1, 1 stays the same, and 2, 2 stays the same. Okay, so let's go ahead and connect our dots. And yep, sure enough, it's reflecting over here into the 4th quadrant. So our graph is reflecting over the line, so we found the inverse using y equals x, and we found our inverse using a table. So that is how you find an inverse.